Good afternoon. I'd like to welcome you all to my upgrade of my Genmitsu CNC router. We had just got this in a few days ago, and I've already been doing a little bit of work to it. As you can see, it's not completely stock right now. Um, I know in the past I've always just, started up videos, and I haven't really given you a biography of myself, so I'll give you a little information on my background and such. So started off in 1989 with a 7-year apprenticeship in a machinist organization, and we're a small shop, and I was privileged to have that. And in that time, I decided that I wanted to be able to talk with engineers because I know the two were pretty much at a battle. The engineers this way and the machinist hates the engineer, and I wanted to know why. So that's when I started my mechanical engineering. I got a bachelor's in mechanical engineering, and then I wanted to learn a little bit about fixture design and just different applications in basically, the machining world, I guess you would say. So I ended up getting an applications engineering degree, and I got an associate's in that. And ever since then, pretty much I've been a CNC programmer for the last 20 years, 5-axis, 3-axis, lathes, and mills. I've pretty much worked in all kinds of industries. I've done everything from mold making to tool and die work. It's been just a long road of just different applications, and I did the job shop thing right after my apprenticeship, so I lasted there about 2 years of switching jobs in and out, but I got a ton of experience from lots of the old timers that have been in the field forever. They could whip out a fixture in 3 minutes and have something running. It was just amazing. I'm just so glad I had that experience. All right, so on to what we're going to be doing here is first and foremost, I've built machines in the past, and the one thing that I will stress before you even start cutting anything on the machine is make sure that everything is well protected. As you see, we got our linear rails here. You really don't want those getting filled with any dust or anything like that, as they'll just start eating themselves up. There's a small set of ball bearings that are actually, you can't really see them now, but it's a little carriage that runs on these. And they have ball bearings in them, and they will fill with dust, and before you know it, you'll have accuracy problems. Things will start binding up a bit. The other thing is your limit switches. You don't want those getting all corroded, and if you're going to use a water-based coolant or something, you don't want those getting all wet, because before long you'll send your axes home and they won't be returning the same, and you won't be able to come back to your Z and your X0, and all of that will be off just by a little bit, all because of that. The other thing is your ball screw. You don't want that getting all contaminated, because then that goes into another set of another carriage that is lined with balls, and they're in a circular path. You don't want those getting filled up. Then we have our Z-axis and our exposed ball screw. So we want to cover those up. That is the first thing you really want to do. I know everyone gets excited. Your machine comes in, you just want to machine stuff. And that's all fine. But you will learn a valuable lesson pretty quickly when you start doing this. I know I did. My first machine is now pretty much, I was constantly fixing it. And I knew better, but I just wanted to make parts. So on to what we're going to be doing. Is the first order of business is we're going to make some way covers. They're going to cover this whole thing here. And that way there are no dust, no chips, anything will get on the inside of that. We'll also make covers for our Z-axis. One thing I noticed here though is the front side, that's going to be relatively easy to create a bellows system that will work and keep the dust and the chips out. But the back side here is going to be a little more complicated. And the reason being, I figured that I could use, you know, the first side just over here, just in reverse, no big deal. Well, that's not going to be so easy because we have this in the way. And so all of that travel that you see here is going to move here as well. So we're going to be hitting this. So that's going to take a little bit of finesse work there. But we'll be able to get through it. We just need to design something that's going to work in the assembly drawing. And we'll show you that. We also have a little bit of a area here we need to close up a bit too. And we'll work on that a bit. So some of the work that I've already done is all of these holes here, they come standard, they're metric. And I generally work in English threads. So I use a quarter 20 tap, and I retapped all of those holes. So now they're all quarter 20. And the reason I did that is because just that hardware is easier for me to buy. And I can get it at my local hardware store if I need to. Metric, on the other hand, is pretty much iffy. I mean, sometimes, you know, if you go to Home Depot and you want to spend, you know, $8 for a screw, then that's that. But I just tend to order in, you know, bulk if I can. And just a standard size screw for me is just what I need to use. The next thing I did was I bought a 2.2 kilowatt spindle. It's about 2 horsepower, and it does come with a motor mount, as you see here. But what I did with this motor mount, because you want this to be trammed in, you know, square and perpendicular. I built an arbor, the same size as this motor, and then I fastened this onto it as if it was being, you know, it was holding the motor. And so this whole arbor that I made, I put into the lathe and I trued it up, made sure it ran perfectly straight. Everything was all dial indicated in. And then I proceeded to face this side and face this side square to the bore. Then after I had that done, I knew that this was all, you know, square and perpendicular. Then I came and I machined a boss on here, which was square to everything else. So this is as square and as perpendicular as it's going to get, as the machine allows me to right now. We're gonna have to make some adjustments, of course, once we get going, but that's beside the point. This table, unfortunately, is nothing more than just a piece of plate stock. So it's a little bit bent, it's warped. And, you know, we could, you know, get a nice piece of 1/2-inch aluminum and machine this, fly cut it all, put the holes in. But I'm not going to really go and do that. I'm just going to rely on my fixtures. And once I true them in, then I'll be able to get an indicator in there, and I'll be able to tram in the head a lot better and to the fixture, because I'll see which way it's cutting when we fly cut it. So the first order of business is I'm going to be using SolidWorks, and I'm going to design all of these way covers in SolidWorks. I'm going to do an assembly drawing, and basically an assembly model, I should say, of this whole machine. And the reason why I might do that is so, for one, I can fit parts when I make my assembly, and I know that everything's right and it will work, and I won't have to make parts 3 or 4 times. And the second thing that I'm going to make this whole model is for, in my CNC software, I'll be able to use this as a simulation machine. And so when your parts are on the table, you'll be able to visually see this machine cut your parts, and you'll know if you're going to crash or anything. It doesn't need to be done, but I'm going to do that. And if you guys want videos on how to build a simulation machine for CNC software, I'll gladly take you through that process as well. So I guess we'll get cracking on these weight covers. And if you want to follow along, that's great. And I thank you for watching. Alrighty, have a wonderful day.